Welcome back. This is part 2 of our discussion on evolution. In part 1, we finished by looking at Darwin's grandfather, and this one we're going to pick up by looking at Lamarck. So Lamarck was more in the 1800s in terms of a timeline. Recall Darwin and Buffon were from the 1700s, so this came a little bit after, and more along the same time frame that Charles Darwin himself was actually at work. Lamarck observed life, and he thought that every single thing that was alive lived their life and did things in a way that allowed them to be the best possible thing that they could be. And he called that evolving towards perfection. So what does that mean exactly? It means that whatever you are, you're going to do things to become the best possible version of you that would exist in a given environment. We'll take a look at a few examples of this shortly. Now, before we talk about the information on the screen here, something that we probably should talk about is beliefs back in this time frame. People did not believe that the Earth was more than a few thousand years old. People also widely did not believe that anything on our planet changed. And Lamarck is kind of going against the grain and saying that the environment does indeed change. And as a result of the environment changing, in order for living things to survive, they have to change with it. And that kind of makes sense if you think about it. For example, if it all of a sudden hit, really cold temperatures and we went into an ice age again, in order for most animals to survive, they would have to grow hair. If they grew hair, they might have a chance to survive because they would be a little bit warmer. So that seems to align fairly nicely in terms of understanding. But we're going to look at this a little bit further. Lamarck argued that if one living thing, an individual organism, changed or adapted in a way that caused a physical appearance, a change in their appearance, then this change would be passed to all of the original individual's children. And he called that thought the inheritance of acquired traits. So we're going to break this down in terms of inheritance of acquired traits shortly, so you can see that this is actually kind of not accurate at all, frankly. What we have to think about with Lamarck's logic is what exactly inheritance means. Now, when you think of the word inheritance, you probably think along the lines of something that you get from your family, something that's handed down to you. Well, we can inherit genes, we can inherit traits from our parents, we already know that. But what Lamarck was talking about in terms of inheriting are things that the children didn't have to acquire. They didn't have to work to get these changes. And it doesn't exactly work that way. In order for an organism to pass genes down to their children, those genes have to be in the DNA. If you physically change in a way that changes your appearance, that's not in your DNA. And that's part of the problem with Lamarck's thoughts here. Let's check out a few examples of exactly what I mean. So according to what Lamarck is saying, he's saying that if this crab, for whatever reason, chooses to use this claw, that claw is going to get stronger. And as a result of this crab working really hard to get this strong claw, all of his children are going to have that strong claw as well. And here's why that doesn't make sense. Take a look at Hulk Hogan here. Big buff dude. How did he get these muscles? Obviously, he worked out in the gym and put in a lot of time and a lot of hours. And frankly, anyone that wants to put in that much time could get those muscles too. But what Lamarck is saying is because Hulk Hogan worked out really hard to get these muscles, his son is automatically going to be gifted those muscles without even having to step foot in the gym. And that's where Lamarck is incorrect. His son could get those muscles too if he works out hard himself. Moving on to a new topic related to evolution, and that is gaining support, looking at the geology of our planet. So going back to some of the things we talked about just a short while ago, we have to understand the time frame and the thinking that people had really not that long ago, a couple hundred years ago. So these are some of the popular beliefs of just a few hundred years ago. The common belief in terms of the age of the planet was that Earth is only about 2,000 years old, which doesn't add up because dinosaur fossils are 60 million plus years old. People also argue that our Earth, the planet, it doesn't change, it has never changed, and it never will change. Everything today is exactly how it's always been. And another popular belief was that everything that's alive is not related to anything else that's alive. So we're going to look at how some of these thoughts kind of contributed to actually us understanding the process of evolution a little bit better. There are 3 ways that the planet can change listed on your paper. The first is catastrophism. This refers to a catastrophe that happens resulting in a change in our planet. So what we have to think about is when these catastrophes happen, how does that affect life? So looking at the image on the left here, we can see that there's a volcanic eruption occurring in the middle of the ocean. How is that changing our planet? Well, slowly there's an island chain forming as a result of this volcanic eruption. That's actually how the Hawaiian Islands came to existence, is many repeated volcanic eruptions leading to the Hawaiian Island chain, which now allows life to live there. So how could this volcanic eruption possibly impact life on our planet? Well, maybe some new life forms will arise and start to live on these planets, or on these islands. Looking at the image on the left here, we can see a flood has occurred. How would this flood have impacted life in this particular city? Well, it probably killed a lot of living things, so it might have caused some species to possibly go extinct if they didn't have the ability to climb up telephone poles. And heck, even once they're up there, do they have access to food? So catastrophes, sudden problems like eruptions and flooding can alter life. And that simply would be allowing life to either possibly increase or possibly decrease. The second form of planetary change is called gradualism, and that makes sense because it is talking about slowly changing landforms occurring over many years. An example would be the Grand Canyon that we see here on the left. We know that the Colorado River has been cutting and grinding away at the canyon, making it deeper and deeper for many years. It didn't happen overnight. Looking off to the right here, this is showing you cracked pavement, which is characteristic pretty much anywhere where there is snow in the winter. What happens to cause this would be you get snow, the snow melts, then it freezes at night, then it melts again during the day, freezes again at night, causing the ground to contract and expand, causing these cracks that we see on the concrete. So how does this support the theory of evolution? Well, this ties back to people's belief right here, that the Earth does not change. Well, it does. This is hands down proof that our planet changes. And people started to realize this, and people started to think, hey, we were kind of wrong about our belief in terms of the planet not changing. And that led for people like Darwin to realize, well, maybe if we were wrong about the planet not changing, maybe we're wrong about life not changing either. Maybe life, in fact, does change, which is how gradualism supports the theory of evolution, starting to realize that we were maybe wrong in some of our prior logic. And the last form of planetary change that we're going to be looking at is called uniformitarianism. Now, if something is uniform, that means it's staying the same. And this is an extension of gradualism. Uniformitarianism simply states that the things that are causing our planet to change today were the things that caused our planet to change millions of years ago. And they're going to be the same things that cause our planet to change in the future. So volcanic eruptions, they cause our planet to change. Maybe that's the formation of a new island. that happened millions of years ago. It's still happening today. Floods, they change the course of our planet. They always have. They always will. So this is contributing to the theory of evolution in regards to how evolution occurs. The way that evolution occurs today is the same way that it has occurred millions of years ago. And we'll talk more about the specific ways that individuals and populations can evolve once we start looking a little bit more closely at it. To kind of give you an idea before we actually get there, it happens at the genetic level. We'll talk about more of that a little bit later.